Hello everyone, welcome to the course of Algebra 2 with Kajal Bamotra. Here in this lecture, we will going to start the lecture 1 for the chapter number 1. So first chapter is linear functions. So we will start from the basic and cover all the level of Algebra 2 here. Okay, let's start it. So here we will talking about the parent function. What is a parent function? The very basic function is known as a parent function. So I will write the most basic function of the family is known as a parent function. Let's see some examples. I have a function fx is equals to x. Fx is equals to some constant. Fx is equals to absolute value x. And fx is equals to x square. So these are the basic function. This one is a linear, this is a constant, absolute value, and that's a quadratic function. So these are the basic function. We talk about the parent function, then we learn the basic parent function. There are more like cube, square root function, that function, but these we are talking about in this one only. So the first linear function is look like this. Fx is equals to x, a linear function. The next is fx equals to 1, which is a constant function, and it will look like this. It's a constant function. And the next is absolute value function. It will be like this. Here and here. Absolute value function. And next is a square. So it's a quadratic function. We are considering this as a quadratic function. It looks like this. Alright. Now we will learn the transformations. As we are working with the chapter 1 linear functions, so we will learn the transformation in the linear functions only. So there are different transformation. The first transformation is translation. In the transformation, the first is translation. Translation means we are shifting the function left, right, up or down. If these four changes are there in the function from the basic parent function, it's known as the function has a shift. You can use the word shift. It shifted left side, right, up or down. It's depend upon how much it's a shift and how much units. So let's write the translation. In the translation, I have a fx. Fx is a parent function. Something is added. So it may be a constant term added at the last. Maybe a constant term subtracted. Instead of adding, it may be subtract. Let's see an example. I write x plus 1. X is a parent function. Linear parent function fx equals to x. What I did, I just add 1. So what I will use? I will use it's a translated 1 unit up. Here if it is a, it's a function is translated a unit up. If a it become negative, a is a positive quantity and I'm writing fx negative a, then it will be a units down. If instead of outer addition or subtraction, the addition and subtraction is going inside the x, it's like x plus a, it means the function is shifted a units left. So it's a unit left. If I subtract a, it will be a unit right. Okay, let's have an example. See the first function gx. Gx is given as a x plus 2. We know that simple x is a basic function, linear function. Plus 2 is just it's a translation. So it's a 2 units up. If you see this hx function, it's absolute x minus 1. It is 1 unit, right? You can see, because we know that the basic absolute function is this. So what's the difference between these two? 1 is subtracted, so it's a 1 unit, right? The next is reflection. It's reflection. Reflection is of two types: reflection in x-axis, reflection in y-axis. If your function fx is multiplied outside, the parent function is multiplied by a negative outside, it means the function is reflected in x-axis. If I change x as a negative x, that means inside the x negative is multiplied, so the function is reflected, the original function fx is reflected in y-axis. Let's have an example. So I have an example, fx is equals to x square. This is the basic function, and how the graph of this x square look like, we already learned at the starting. The graph of x square is look like this, okay? And what I'm changing it, I'm multiplying negative outside the function. It's a new function gx. If I compare with the this properties, negative is multiplied outside. If it is multiplied outside, so it will be reflection in x-axis. So if I'm drawing graph this, it will be just the same graph, but it's reflected down. So it's a reflection in this x-axis. So x-axis worked as a mirror and the upward part shifted down. Okay, so that was the second transformation, reflection. The next transformation is shrink and stretch. Stretch and shrink. So if I function fx, and fx is basic function, I multiply by a constant term outside, the whole function is multiplied by constant number a. So it means it is a vertically stretch or shrink. And how to identify stretch or shrink? It depends upon a. If a is greater than 1, then I will say it is a stretch by factor a. So if a is greater than 1, it's a stretch. If a is between 0 and 1, it's a shrink. We are trying here some questions, some exercise questions of the book. So first, here the question says that identify the function family to which f belongs. Compare with the original and its parent function. So what is the original parent function, you can say, for this? Have you seen this absolute sign? So this function is belongs to absolute function. So it belongs to absolute value function. Absolute value function. If you see this one, it's a quadratic function. Here it's a constant function. And this one is a linear function. Okay, that was exercise question that we covered. Next, in this exercise question, they are saying write the parent function, then tell us the transformation. What is the transformation applied to the original function to form this function? I will try the question number 11. In the question number 11, we are given that the function fx equals to x square minus 1. What is the basic function? Here, the basic parent function is x square. It's a quadratic function. And what is the extra thing? Minus 1. Whenever extra outside thing added or subtracted, it's a vertical translation. So minus 1. So that means down. So function is shifted 1 unit down. Which function? Original x square function. So it's a shift 1 unit down. You can use the word vertically. It's a vertical translation. Translation 1 unit down. If I see the question number 16, what is the gx function? The gx function is negative x. Did we learn any negative x function? No. We learn only the function x. Then what is the change here? The negative sign is multiplied outside the function. So it means reflection in x-axis. reflection in x-axis. Okay, so question number 18, you can check. What's the question number 18? Fx is equals to -2. What was the constant function we covered? Fx equals to 1. What is that? It's 2. So here is a two transformations applied. First is 1 changed to 2. How 1 changed to 2? Multiply by 2. Whenever a function is multiplied, it's a vertical, and now it says shrink or stretch depend upon the value. It's a 2. We multiply by 2. 2 is greater than 1, so it's a stretch. So vertically stretch or vertical stretch by factor 2. Then what about this negative? A function is multiplied by negative, it tells us it's a reflection in x-axis because negative is multiplied outside. So it's a reflection in x-axis. So next we are at it now 1.2. In the 1.2, whatever the transformation we covered in the previous chapter, the same transformation but the function is changed. Now the function is the absolute value function. We will use here absolute value function. So let's try the first question. It says the function is 3x and I want to translate the function 5 units up. So original function is 3x. I have to shift 5 unit up. Up means just add 5. This is the new function gx. Second question, try the second. Absolute value x minus 3. This is already given. What we have to do? We have to translate this function 4 unit right. Whether left or right, we have to change this inside the x. So it is 4 units right. So that means absolute x minus 4. Minus 3 as it is. This is the new function gx. So third question. Third is fx is equals to negative times the absolute of x plus 2 minus 1. So I have to reflect this function in x-axis. Reflection in x means multiply the whole function with the negative 1. So the new function gx will be x plus 2 negative negative plus 1. That's the new function gx. Okay. Now the question number 4. Fx is equals to 1 by 2x plus 1. I want a reflection in y-axis. When we have to reflect in y-axis, only change x to negative x. So 1 by 2 as it is. Instead of x, I will change negative x. Whatever the power. If it is a power 2, I have to still take the power 2. And the changes inside the term. I'm again telling you. It will be inside. So if you open the bracket, it will be negative x by 2 plus 1. Done. So that's a gx. Here we learn vertical stretch and shrink. Here this is we learn when a is multiplied outside, that is talking about the vertical stretch and shrink. How the horizontal stretch and shrink work? In a horizontal stretch and shrink, the a is multiplied inside the x, f of ax. Then if a is greater than 1, we will pronounce function it is a horizontal greater than 1. It is a different from the vertical. If it is greater than 1, horizontal shrink. It is a horizontal shrink by factor 1 over a. If a is in between 0 and 1, then I will say it's a horizontal stretch. Horizontal stretch by factor 1 by a. Again, done. So let's have an example. I have a function fx is equals to absolute 3x minus 1. I have to explain what are the transformation used here. So if you see what is the basic function here is absolute x, and this is the new function after applying the transformation. The first transformation is applied, your x is changed into 3x, and 3 is not multiplied outside, 3 is multiplied inside the x, inside the absolute term, so inside the absolute bracket. So it's a 3. If it is multiplied 3 and 3 is greater than 1, so I will use the word horizontal shrink. Horizontal shrink. How much? What is the factor? By factor 1 over 3. First transformation. What's the next? It's a negative 1. Whenever extra term, outside term, added or subtracted, it's a vertical up or down. So negative 1, that means down. It's a 1 unit down. Okay. So these are the exercise questions of 1.2. The 17 question number says we have to write the new function g from f using the given transformation and then use a graphing calculator to check the answer. Let's see. I'm trying question number 17. Fx is x plus 2. And what I have to change? It says vertically stretch by factor 5. Vertical stretch, that means multiplied outside. So it's a 5 times fx actually they are talking about. 5 is multiplied with x plus 2. So 5x plus 2. So I will write here. Here I will draw the graph of fx. And here I will draw the graph of gx. Let me show you how the graph will look like. Here it will be 5x plus 10. Okay, now let's see the graphs. So this is how the two graphs will look like. This is fx, which is x plus 2. This is gx, 5x plus 10. So let's see, what does it mean? It means it was a vertical stretch by factor 5. So I am stretching it vertically by factor 5. So it's a by factor 5 I'm stretching it. So it's a stretch and going up, and it will be creating like this. It's go up, it's stretching up. It's like this. Okay. So this is how the graph look like. You can see it's look like exact the same as the green colored graph. Okay. All right. So this was 1.2. We have a two types of equation. Basically, we write general linear equation will be written as it's a slope intercept form. Y equals to mx plus b. This is known as a slope intercept form. And another is y minus y1 equals to the slope x minus x1. This is known as a slope point form because the x1 and x2, x1 and y1 are the points. It's a slope point form. So here's the exercise question. I have to write equation of line and we have to write what is the slope. Interpret the slope. So if I look at the question number 3, there are 2 points, 10, 2, 0, 0. So 0, 0 is the one point, 10, 2 is the another point. I want a slope. What is slope from the 2 points? Difference of y values over difference of x values. So 2 minus 0 over 10 minus 0. I will get 2 over 10. 2 over 10 is 1 by 5. So slope is 1 by 5. And you can see the line cuts at a y-axis at point 0. So I got the y-intercept as well. Y-intercept, that means b. b is 0. So what's the equation? Y equals to 1 by 5x plus 0. I use the equation mx plus b. M is 1 by 5. B is 0. Okay. Let's try question number 4. They are already giving you this is 90, this is 3. So slope will be, what is the x change? What is the y change? Y shifted down. If it is a down, so negative 3. What is the x change? X change to 90. So 3 over 90. Negative 3 over 90. It will be negative 1 by 30. At what point they are intersecting? They are intersecting at a point. It's somewhere. This point is given here, x value is moved here 90. So it's a 0, 4, 8, 12. So this point is 12. So y intercept is 12. Y equals to negative 1 by 30 x plus 12. Done. That's the equation of line. In this video, we will leave up to this. The remaining we will continue in the next class. Thanks for watching.